Think about the last time you woke up super early to catch a beautiful sunrise. You're standing there, taking it all in, but what if I told you that you're actually looking at an optical illusion? Yeah, you're literally seeing the sun before it has physically arrived.
Here's what's actually happening. The sun's light is passing through Earth's varying atmospheric layers, and those layers, they act just like a giant lens. They're bending the light, projecting an image of the sun above the horizon before it's actually there physically. It's just everyday physics making this happen right above us.
All right, here's our roadmap for today. We're covering the sunrise optical illusion, what exactly refraction is, a quick coin experiment, denser versus rarer mediums, Snell's law, and finally, total internal reflection. Let's get into it.
Section 1. The sunrise optical illusion, a cosmic magic trick.
So, get this. This cosmic magic trick lets us see the sun a full 2 minutes before it actually crosses the horizon. For 2 whole minutes, you're just staring at a brilliant projection. The real sun is still completely hidden behind the curve of the Earth.
Let's break down exactly how this works. As light travels from the vacuum of space and hits Earth's atmospheric layers, it goes through a continuous bending process. Because of how the atmosphere is layered, that light bends continuously from left to right. And boom, that distortion creates the perfect illusion of a risen sun. Pretty wild, right? Moving on to Section 2. What exactly is refraction? Defining the phenomenon.
So, formally speaking, the refraction of light is simply the bending, or the change in direction, of light as it travels from one material, or what physicists call a medium, into another. Basically, whenever light decides to change its environment, it's got to change its path.
Section 3. The coin experiment, proving refraction at home.
Now, let's take this from the sky to your kitchen table. You can literally try this right now. Step 1, place a coin in an empty glass, so it's just in the air. Step 2, fill that glass with water to change the medium. Step 3, look at it from the front and observe the shift.
It's like magic. The coin actually appears to shift its position. Because the light traveling from the water into the air changes direction. It bends. And that bending makes the coin look like it's raised up from its actual physical location at the bottom of the glass.
Section 4. Denser versus rarer mediums. The rules of bending light. Now, we know light bends, but to understand the rules of the road, we have to talk about mediums. Light behaves completely differently depending on its environment. It all comes down to whether it's moving through a rarer medium, like air, or a denser medium, like water or a solid block of glass.
And there's a strict rule book for this. When light travels from a rarer to a denser medium, say from air into glass, it bends towards the normal line. It kind of gets pulled inward. But when it goes the other way, escaping a denser medium and entering a rarer one, like water into air, it bends away.
Which brings us to Section 5, Understanding Snell's Law, the math behind the magic.
So, is there a mathematical constant for all this bending? Absolutely. Enter Snell's law. It states that the ratio of the sine of the angle of incidence, so the light coming in, to the sine of the angle of refraction, the light bending, will always give you a constant value for any 2 given materials.
That constant value is known as the refractive index. It basically represents exactly how much light is going to bend in a second medium compared to the first. It's the exact math that calculates that weird shift you just saw with the coin in the water.
All right, our final concept, Section 6, total internal reflection, pushing light to the limit. Let's see what happens when we push these rules to the absolute extreme. Imagine shining a light source inside a denser medium outward into a rarer one. If you keep increasing the angle of that incident light, the angle of refraction goes up too. Keep pushing it until the angle of refraction hits a limit of exactly 90 degrees. If you go even slightly past that limit, the light bends so much it actually can't escape at all, and it bounces perfectly right back inside.
We call this total internal reflection. Because the light cannot pass the boundary, the angle of incidence and reflection become completely identical. You've effectively turned that transparent edge into a flawless mirror.
So if the sunrise you watch every single morning is just a daily illusion, where else in your world is light secretly playing tricks on your eyes? From that 2-minute cosmic delay to a shifting coin in a glass of water, refraction is literally everywhere. It really leaves you wondering, doesn't it? What other visual truths in your daily life are just bending light? Thanks so much for joining me for this explainer, and keep questioning what you see.